what is the value of 1 to the power infinity? Using a limit, I will show you it can be any positive number, but not 1. So consider k. For any k greater than 0, but k is not equal to 1, let's consider the limit. Limit x approach infinity, 1 plus 1 over x to the power ln k times x. You see, when x approaches infinity, the base is 1 plus 1 over infinity, which is 0. 1 plus 0, so the base is 1. The exponent, if k is not equal to 1, then ln k is not equal to 0. So this number times x still infinity. So we get 1 to the power infinity. Right? Now I will show you the limit is exactly k. To do that, let y stands for the expression. So let y equals 1 plus 1 over x to the power of ln k times x. Apply ln to both sides. So we get ln y equals ln 1 plus 1 over x to the power of ln k times x. We can put exponent in front of ln. So we get ln k times x, and then times ln 1 plus 1 over x. You can further write as ln k, and we write that as ln 1 plus 1 over x. I put x at the bottom, becomes 1 over x. So you see, when x approaches infinity, here this part approaches 1, so the top approaches 0, the bottom again approaches 0. So there's 0 over 0 type, right? We can use L'Hopital rule. So the limit when x approaches infinity, ln y equals, I can take this out, so ln k limit x approach infinity. Before applying the L'Hopital's rule, we change the top as ln 1 plus x minus ln x, because we can write this one as ln 1 plus x over x, and then use logarithm property, right? So we get that, and the bottom keep that. Now we apply L'Hopital. So ln k times limit x approach infinity. The derivative of the first term equals 1 over 1 plus x. The derivative of the second term, 1 over x. The derivative of the bottom equals negative 1 over x squared. So we get ln k and then limit x approach infinity. We can combine the top. So it is 1 plus x times x. The top is 1 plus x minus x, which is x minus 1 plus x. So it will be negative 1. The bottom, negative 1 over x squared. And then top and bottom multiply by negative x squared. So right here, so multiply negative x squared. So we can just cancel the bottom, right? So then we get ln k, and then limit x approach infinity. So we the top we get x squared, and the bottom 1 plus x times x. Now top and bottom divided by x squared. So we get ln k limit x approach infinity. So the top becomes 1. The bottom, that divided by x, we get 1 over x plus 1 x divided by x just 1, right? So you see when x approaches infinity, the limit becomes 1 over 1, which is 1. So the limit is ln k, right? So the target limit, the limit x approach infinity, 1 plus 1 over x to the power ln k times x equals, because we didn't know y as that, so we get limit x approach infinity y. But using logarithmic property, we can write y as e to the power ln y. Now, e to the power x is continuous, so we can put the limit sign up to the exponent position. So we get e to the power limit x approach infinity, and then ln y. Now we know the limit ln y equals ln k. So we get e to the power ln k. You know, that is exactly equal to k. So that means 1 to the power infinity can be any positive number, but not 1.